This is problem 22 from the Kinematics review. You're on top of a 100-meter high building, thinking it would be cool. You throw a penny up at a speed of 25 meters per second and watch as it then falls to the ground at the base of the building. What maximum height does the penny reach? How fast is the penny going when it hits the ground? And how long is the penny in the air before it hits the ground? We're going to have to break this problem into a couple of different parts because it's asking for information about two locations. The first thing it's asking is, what is the maximum height? And these are the kinematics variables for that. The initial speed when it's thrown is 25 meters per second. At the maximum height, the VF is 0 because it stops for just a moment, an instant, before coming back down, and the acceleration, as always, is negative 9.8 meters per second squared. That's going to be very different than the second two questions it's asking, which is how fast is it going when it gets to the ground and how long does it take to get to the ground, because when it gets to the ground it's not at the highest point anymore, it's at the ground. So we have a completely different displacement. So in part one we're looking for a maximum height. For the last two questions we know where the thing is going to be. It's going to be at the ground. So we have to do two different sort of problems to solve for the things that we're looking for here, because you can't do one set of kinematics variables to find the information about a problem when it's at multiple locations. So first we're going to take a look at this maximum height when it reaches the highest point. We do not have time, so we're going to use the equation that doesn't have that in it, which is VF squared equals V naught squared plus 2AD. We're solving for the displacement, so we're going to subtract V naught squared to the left first, giving us VF squared minus V naught squared in the numerator. We're going to divide by 2a to get d by itself. That's why it's down here in the denominator, and then we can plug in our numbers. 0 squared minus 25 meters per second squared, all over 2 times negative 9.8 meters per second squared. And we plug that in our calculator, and it gives us 31.9 meters for a maximum height. That's obviously above where you threw it. If you were going to add in the height of the building, then the maximum height would be 131.9 meters above the ground. In this case, it was just answering above the building. Either answer would be correct. Now we're going to solve for how fast the penny is moving when it gets to the ground. Well, we know that the displacement is negative 100 meters because the penny is going to be 100 meters lower than where it started when it gets to the ground. Initial speed is still the same. It's still upward 25 meters per second, and the acceleration the whole way up and down is negative 9.8 meters per second squared. We're going to look for the equation that does not have time in it, because that's the thing we don't have, and that's going to be VF squared equals V naught squared plus 2AD. We're solving for VF, so we just have to get rid of the squared by taking the square root of everything on the right side. You can see I've done that in this step here. Once we plug in our numbers, we get VF equals the square root of 25 meters per second squared plus 2 times negative 9.8 meters per second squared times negative 100 meters. That's going to give us a final velocity of negative downward 50.8 meters per second. The negative makes sense because the penny is going to be moving down when it gets to the ground. Now we're going to solve for the time. We're going to use the equation. We could use the equation that does not have VF in it. Then we'd be doing a quadratic. A lot of people don't like to do that. In this case, I did not, because I'm pretty confident my VF answer is correct. Don't forget your negative, by the way. When you plug this into your calculator is going to say 50.8. It's not going to have the negative. If you don't remember to put the negative there, that's an incorrect answer. Plus, if you try and use it later, you'll get really weird wrong answers. So make sure you remember your negative. This thing is moving downward. So we're going to use the equation. We can use any equation we want, actually, but we're going to use the equation VF equals V naught plus AT to solve for time. I'm going to subtract V naught to the left. That's why we have VF minus V naught. We're going to divide by acceleration to get t by itself. That's why it's in the denominator. And now we can plug in our numbers. Negative 50.8 meters per second minus 25 meters per second, all divided by negative 9.8 meters per second squared, gives us a total time that this penny spends in the air of 7.7 seconds.